In previous video, I have introduced you to this subject or this course, right? So in today's video, we are going to see how to represent a vector, what is a unit vector, and how to perform vector algebraic operations like scaling, okay, addition, subtraction of at least two vectors. Okay, so let us start with representation of a vector. So let us see how to represent a vector. In two dimension, a vector can be represented by a straight line with an arrow in a plane. Okay, that means any vector will have a starting point and a terminating point or end point. Okay, so vector can be represented as a straight line like this, where this point, okay, this can be treated as the starting point, and the other point can be treated as end point. Okay, so this is end point. Okay, now this is a straight line with arrow as stated, so it should have an arrow at the end point. So this arrow represents the direction of the vector. Okay, so the magnitude of the vector is from the starting point to the end point. Okay, so this gives me the magnitude of the vector, and this arrow represents the direction of the vector. Okay, now if I name this starting point as something like O and end point as A, so this vector can be written as OA vector. Okay, so this is how a vector is represented, or simply I can write this as A vector. Okay, I can write it as A vector. So the magnitude, okay, if I measure the length from O to A, so the magnitude can be written as A vector minus magnitude. Okay, so it can be written as A vector. Okay, so this gives me the magnitude. Now, how to represent this mathematically? Okay, so this is actually symbolic representation. Okay, this way of writing this A vector is symbolic representation. Now, if the starting point, okay, let us consider this in two dimension as stated earlier. Now, if the starting point, when I say two dimension, okay, I hope you know this is x axis, okay, this is y axis. So I am keeping this OA, okay, somewhere here like this. So it is this in this two dimensional axis. So it will have starting point, it will have end point, right? It will have a starting point, it will have an end point. Okay, so let us maybe if required, let us represent it in a better way. Okay, so I have x-axis, I have y-axis. Okay, I draw a vector something, okay, something like this, something like this. This is my a vector. Okay, so I extend this y-axis to the negative side, I extend this x-axis to the negative side. Okay, this is the origin now. Okay, this is the origin O. So now we see this is some point maybe -1. Okay, this is also some point maybe -1. Okay, so this is -1 on x-axis, this is -1 on y-axis. Okay, in the 6, but what I need is the starting point. Okay, so this is my starting point. So on y-axis, maybe this is the it is -1, and on x-axis, okay, let me consider this as -2. Okay, so I have, okay, so sorry, I'll repeat. On y-axis, let it be -2, and x-axis it is -1. Correct. So I write this starting point of this vector, starting point of this vector as -1, comma -2. Agree? Now the end point may be, the end point is, okay, this may be x equal to 4, okay, and this may be y equal to 3. Okay, just for example, y equal to 3. So the end point of this will be 4 comma 3. Is it very clear? 4 comma 3. Okay. Now how I write this vector? Okay, how I write this vector? So this A vector can be mathematically represented or written as the end point minus starting point. Okay, so how I write end point? So first I take x2. Okay, this is okay. If I consider this as x1 x2 generally, x1 y1 generally, and this is x2 y2. Okay, starting point as x1 y1, end point as x2 y2. So generally I write this as x2 minus x1. Okay, in x direction. Okay, we'll discuss about this what is this, okay, x cap, what I'm trying to write later, okay, in detail later. Don't worry about it now. And y2 minus y1 in y direction. This is how generally I write it. Okay, similar to, okay, distant formula. You find endpoint minus start point, right? So always you have to remember, okay, this can be treated as head of a vector, okay, and this can be treated as a tail of a vector. So it's always head minus tail. I'm repeating this because later when we do vector computations or analysis, most of the students make mistake while representing a vector if endpoint and start points are given. So always it is endpoint minus start point, okay, with respect to the axis. Okay, so if it is x and y points, it will be x2 minus x1 and y2 minus y1, okay, with respect to the direction vectors. Okay, so here what are the points I have? I have x2 as 4. Okay, so a vector can be written as 4 minus, what is x1? Minus 1. So this becomes 4 plus 1. Agree? Ax cap plus, what is y2? 3. Okay, and what is y1? Minus 2. So I get 3 minus minus 2. Okay, so 3 minus minus 2. So that is plus 2. So that is ay cap. Correct? So I get it as 5ax cap. Okay, so that vector representation will be 5ax cap plus 5ay cap. Okay, now this can be easily extended. Okay, this idea can be easily extended to 3 dimension. So in a 3 dimension, okay, so or this particular formula or this representation is basically 5ax cap plus 5ay cap plus 0 az cap. Is it not? 0 az cap. What is this az cap? This az cap represents the third axis, that is z axis. So when you are going to represent the system, okay, so now I am talking in xyz coordinate system, or it is also known as Cartesian coordinate system. We'll study about these coordinate systems in later videos. Okay, nothing to worry. But generally most of us know, right? We represent using xy axis, and if there is third dimension we use xyz axis. Okay, so this is basically when z is 0. If it has some value, okay, I'll not draw it again, but I'll just put a value here to have a feel of it. So I can write this as 5x cap plus 5ay cap plus some value 3az cap. Agree? So now this representation is in 3 dimension. What does it mean? So the vector, like the previous diagram, the vector will have x1, x2, y1, y2 as well as z1, z. Okay, please try to draw yourself an xyz axis and draw an a vector and try to represent x1, y1, okay, z1 and x2, y2, z2 respectively. Okay, so you'll get something like this. Now generally I can write this as a vector as ax cap plus ay cap plus az cap, right? Agree? No harm, because this ax represents 5. This ax is just a representation, okay, magnitude. This is just a value, scalar. Okay, so ax is just a value scalar, so x is 5. Okay, ay is also 5 and az can be 3. So in generally I can represent a vector as x cap plus ay cap plus az cap in 3 dimensions. I hope this is very clear now. How to represent a vector is hopefully very clear. Is it not? Okay. So what is this? What is this ax cap, ay cap, az cap? Okay. They are known as unit vectors. Okay. What are they known as? They are known as unit vector. So let us see what is this unit vector. Okay. What is significance of it? What is significance of this unit vector? So unit vector is basically, okay, it acts as a function to represent the direction of a vector. Okay, we'll start with that. That means I have a vector like this, okay, OA, which is a vector. Then the direction of this vector can be represented with another vector. Okay, it's a representation. Okay, so it can be represented by another vector. Okay, that is nothing but a cap. Okay, whose magnitude is what? The length of this, right? Whose magnitude will be 1. Very clear? So this, okay, this act as, okay, this act as a function of representing the direction of my main vector a. Clear? That is very clear. It just acts as a, yeah, function in representing the direction of this vector, a vector. And as you can see in the figure, the magnitude of is 1. That's why the name unit vector. The magnitude is unity. Okay, so the name unit vector. So the name unit vector. Actually, basically, that is the significance of unit vector. So in the previous example, when I write a vector as ax x cap, what does this basically mean? I have, okay, just assume that ay and az is 0, so that you will not have ay cap az cap. Okay, so if I write a vector as ax x cap, what does it basically mean? Basically means, see, I have x-axis, y-axis, okay, 2 dimension, and I have a vector, okay, I have a vector a, which is having a magnitude, okay, magnitude ax, which is having a magnitude ax, that is this magnitude, this from here, from the origin to this end point, the magnitude is ax, and it is in x direction. X direction is represented using a unit vector ax cap. Agree? I hope it's very clear now. Okay, so any given vector can be represented as two parts, magnitude and its direction. So magnitude is any value, like previous example 5, 3, okay, some scalar value, and this ax cap is unit vector representation, which gives you the direction of this actual vector. Okay, so what you have to remember here is the magnitude of this, right, x cap, so is 1, so it will not affect in mathematical computation. Means if this is 5, okay, if I do some scalar, we'll study about vector multiplications later, okay, whatever, but if this is, since the magnitude of this is 1, okay, the value will not alter. This is 5 into 1, 5, it remains as 5, and so this will just give me the direction. Is that very clear? It just gives me the direction. Okay, now basically, okay, you will have a doubt now. How, okay, can I compute this unit vector x cap? Is it just a representation, or can I find a value for that x cap? Value, when I mean, can I compute? Okay, when I say x cap, it's very clear, right? It is in which direction? Which is in x direction. What if I say it is a cap? What if I represent a unit vector as a cap? Now what is the direction of that? If it was ax cap, if it was ay cap, it was az cap, it's very clear to you that it's an unit vector in that particular direction in xyz coordinate system. But if I write a cap, then, okay, you know that the magnitude of this is 1. Agree? But what is the direction? What is the direction? Yeah. So there should be, it's difficult to judge, right? So there should be a way, okay, to express unit vector or to find the actual direction of any given unit vector. Any given unit vector. So let us discuss that next. Okay. Yeah. So if I know, okay, if I know a vector, what do you mean by if I know? If I know the magnitude of this, okay, how much it is, some value 5. And if I know the direction of this, okay, some direction. So I know the end point and starting point. Okay, so you know how to represent a vector. So if I know the representation of this vector, that is, it is something like 5x cap, okay, plus 6ay cap, plus 3az cap, okay, if that is lying on an xyz axis, okay, something like this. If I know, then any unit vector, okay, any unit vector, when I mean the unit vector representing the direction of this vector, a vector. That's why the suffix capital A. Is that very clear? So this unit vector gives me the direction of this capital A vector. Okay, so that can be expressed or that can be computed as that vector, that is A vector, divided by magnitude of that vector. So this is how I express any given unit vector. Okay, so any given unit vector A cap is that vector, okay, which I am representing here. So here it is A vector divided by magnitude of that vector. Okay, so this is basically expression or definition of unit vector. And always, okay, you should not have any doubt, always we use small a to represent unit vector. Okay, throughout this course I will be using small a with a cap to represent unit vector, and based on which vector I am representing, the suffix will change. If it is b vector, I will write it as ab vector cap. Okay, if it is c vector, I will write it as ac vector cap. Okay, if the direction is already known to me, I will write it as x cap or ay cap. Okay, in xyz coordinate system or as. I hope. So just now we have expressed unit vector, right? We have defined unit vector. Okay, so now for the calculation of unit vector, it is necessary to calculate magnitude of a vector, right? Magnitude of a vector. So how do we calculate this magnitude of a vector? Usually students jump into the equation of magnitude of a vector, or basically magnitude of something as square root of maybe x square plus y square. Is it not, if it is in 2 dimension? Okay, so I am trying here to explain you why it is square root of x square plus y square, or in this case if I take, okay, a vector in 2 dimension, okay, a vector is represented as you know, ax cap plus ay cap. So if I want to find the magnitude of a vector, then this will be square root of, okay, this is supposed to be square root of x square plus ay square. So let me try to explain you why this is square root of x square plus ay square. Okay, it's always not nice to by heart the things. Okay, so it's better to know why it is that. So let me plot this a vector, okay, this particular a vector on 2 dimension xy axis. Okay, so if I draw an xy axis, this is my x axis, okay, this is my y axis, and this is my y axis. Now let me keep my vector the starting point of the vector at the origin, okay, and end point is somewhere here. So this is my a vector. So I need to find magnitude of this A vector. So magnitude of this A vector is nothing but what is the distance from here to here. Agree? Okay. Now see here, how can I find that? I can draw up a line here, okay, which will touch the x-axis, which will give me the endpoint value of x-axis. Agree? And I can draw up a perpendicular line to y-axis, and it will touch where the point of y-axis, okay, which gives me the endpoint. Okay. Now this length is y length, and this much length is x length. Agree? Now see, if I project this, okay, only this portion, this can be viewed as a triangle. Agree? So I am just projecting this area. So I have x length here, I have y length here, okay, y length here. So just projecting this, so this y length, okay, I'm removing this y length here. I'll take, okay, y length the other side, so y length here, okay. So this is my y length, because this length is same as this length. So this is y length, this is x length, and this is my A vector, and this much distance is nothing but magnitude of A vector. Now you can see that this is a right angle triangle, right? Because I have dropped perpendicular lines to the axis, so this should be 90 degree. So this can be viewed as a right angled triangle. So in right angle triangle, if you know x, if you know, suppose if you take some value, okay, you know x, you know y, how can you find this? You can apply Pythagoras theorem, as simple as that, right? So what is Pythagoras theorem? Hypotenuse square equal to base square plus altitude square. So if you take hypotenuse, that is my A vector magnitude, this is nothing but square root of base square, right, which is nothing but x square, then this is y square. Agree? So I get square root of x square plus y square. Okay, so this x is nothing but same as ax, right? Same as ax in this case, and y is nothing but same as ay in this case. So A vector magnitude can be easily written as square root of ax square plus ay square. Agree? Now if this is in 3 dimension, you can extend this for az square also. That's it. So that's how, or that's why the magnitude of a vector is square root of ax square plus ay square plus az square in 3 dimension. So now you know how to calculate magnitude of a vector. So far we have seen how to represent a vector, okay, in a diagram, okay, mathematically. Then we have seen unit vector, okay, what is the significance of unit vector, definition of unit vector, expression of unit vector, and in the course of calculating unit vector, okay, we need to calculate magnitude of a vector. So now we know the basic of calculating the magnitude of a vector also. So we'll continue with vector algebra as I stated earlier in the video. So first we have to see scaling, okay, then we'll continue with addition and subtraction of the vectors.